Today we're going to look at the analysis of the meat content of a sausage, the crucial parts of that being the moisture, the nitrogen and the fat. As part of that process, we will remove the skin of the sausage, as the skin does not account for any part of the meat content. Homogenisation of the sample is absolutely crucial. The homogenisation process involves putting in an industrial blender and spinning at very high revolutions to come up with a sample that is absolutely intrinsically mixed with one another. For all procedures carried out within the laboratory, there are detailed procedures either based on British standards or in-house UKAS accredited methods. The procedure is detailed in such a manner that it is very easy to follow, similar to that followed in any laboratory, including schools laboratories. Nicky's now putting it in the blender, placing the lid on. The safety lock engages and the revolutions start. The sample is now removed and we'll put in a clean, fresh vessel for each sausage and uniquely labelled. The unique barcode label will now be placed in the sample. The process is now ready to move on to the next stage. After the homogenising process, we can now carry out the nitrogen determination on the sample. The nitrogen content is related directly to the protein content associated with the meat and also related directly to the meat content of the sample. The sample is weighed onto a suitable piece of paper. The weight requiring to be known to 4 decimal places. The combined sample and paper is transferred to the digestion tube, awaiting the next digestion stage of the process. We are now going to add the catalyst tablet to the sample. The catalyst tablet consisting of a mixture of potassium sulfate, copper sulfate and titanium dioxide. The catalyst itself will aid in the reaction to progress. We will now also add sulfuric acid and hydrogen peroxide. These are all added before the sample is put on the digestion stage, during which time it will be heated and the proteins within the meat product get reduced to the ammonium salts, allowing for easier later determination. To now continue with the digestion process, the tubes are taken and placed on the digestion block, heated at 400 degrees for 1 hour to continue reduction and breakdown of the proteins within the meat. The extraction hood is placed over the top of the tubes to collect any acid fumes evolved. The acid fumes evolved are then passed through these 2 vessels here, scrubbers to encapsulate any acid fumes, the acid going into a sodium hydroxide scrubber and stop fumes to get put out to the atmosphere outside. The heating process can now continue. After 1 hour, the digestion process is complete and all the protein within the sample has been broken down into its ammonium salts. It will now be placed into the steam distillation units and the ammonium salts, with the aid of the steam, distilled over and collected in a solution of boric acid, which is now being dispensed. The boric acid is placed in the unit with the receiver tip or the dispensing tip below the level of the boric acid due to the volatility of ammonia. As the ammonia salts are distilled across, the red boric acid solution, which has an indicator contained within, gradually change colour, turning green, indicating the ammonia salts are coming across. The green solution contained within now contains all the ammonium salts distilled over during the steam distillation process. This can now be titrated against 0.1 molar hydrochloric acid. The boric acid indicator contained within will change to a faint pink colour when the endpoint is reached. The endpoint can be read directly from the digital burette. The endpoint has now been reached and can be read directly from your bread, in this case 5.58 ml. That can now be used to calculate the nitrogen content of the sample, and from that directly the protein content of the sample. The principles and techniques here of weighing, loss and drying, extraction, reduction, fat extraction are equally applicable to many other consumer products, both food and non-food materials.